Projection of lines. Problem number 14. Three guy wires AB, CD and EF are tied on a 15-meter long vertical post at heights of 8 meter, 11 meter and 14 meter respectively from the ground. The lower ends of the wire are pegged to the ground at points B, D and F at the ground level. If the ends B, D and F from the three corners of an equilateral triangle of side 8 meter, find the length of the wires and the angle made by them with the ground. Assume that the post is situated at the center of the triangle and the diameter of the post equal to that of a line. Select suitable scale. Again, this is also one application problem. So this problem is very interesting. So you can see these kind of problems in your day-to-day life. So this is the pictorial view of it. So at the base you can see the equilateral triangle. So this is the pictorial view. At the base you can see the equilateral triangle which is distanced at 8 meters. So I'm assuming the scale as scale, so that I will copy the scale, same scale. So scale is 1 unit is equal to 10 mm. So 8 meter is 80 mm. So equilateral triangular of 80 mm. So this is the equilateral triangle. From the center of this equilateral triangle we have a pole. Okay, so this is the pole of 15 meter means 150 mm. And from all the three corners of the equilateral triangle, a guy wire has been pegged to the pole. So this is AB guy wire and this is CD guy wire and this is EF guy wire. So AB is tied at a distance 8 meter from the center of a equilateral triangle. Next, CD is tied at 11 meters from the center of equilateral triangle or from bottom of the pole. Next, EF is the guy wire which is tied at 14 meter from the center of equilateral triangle. So this is just a pictorial representation. So in this problem I want to find what is the length of this wire required to tie this at a distance of 8 meter AB, and next CD at 11 meters, next EF at 14 meters. I want to find this length of guy wires required and also angle with respect to horizontal post. So this slope I want to find. So let us find this. So first draw one XY line and then draw the equilateral triangle. So this is 80. So I will change this to A2 size because it won't fit. If you are using A4, it will go out of the sheet. So I am using A2 sheet just to demonstrate. So this is XY line. So this is 80. So angle 60 degree, 60 degree. So just increase this 2 mm. Next smart dimension. So 80. Select these lines and make it bold. Next, draw the projection lines. Locate the center of this equilateral triangle. So these three will be the guy wires seen from the top view. So this is pole 150 meters height. So I will change this to pole. So I will use this. Okay, so I will use this. This is the pole. So next, so from here draw the locus lines. So this is one locus line, the second one and the third one. So go for distance. So from here to here it is 80, here to here 110, so here to here 140. Next from here to here it is 150. Next, wires. So wire I have taken this in this color. So from here to here. Next, from here to here and from here to here. So we can name this text. So this is B, D, F, so this is A dash, and this is C dash, and this is E dash. So this is D dash of B dash. So this is F dash. So this is, first I will name this. So here it is, first you can see E inside bracket C comma A. So just zoom this. So I will name this C dash and A dash. Next I will just draw the locus lines. So this color is this one. Okay, so here I forgot to draw one more guy wire, so that is CD. Okay, so from here to here. So next, so these are the wires in front view, and these are the wires you can see in the top view. So I want to find the true length of this wires, means true length of these lines. These are the apparent lines. So now I am going to rotate these lines and I will make it parallel, and then I will project on the top view. Sorry, from here. So next projection. So this is the point we have rotated, A dash. So it has to be projected till A dash, and it has to connect it for B. So this C dash, so here we have C, so till C and D. So this is point E dash, here till here. So select. Next, smart dimension, just measure the length of these lines. Next, and again I want to find the slope. So I am going to rotate this apparent length in the top view, and I will project into the front view. join. So next again so this is the point we have rotated, that is C. So till C. Next, and again this is parallel, so directly you can find the slope for this. Show the direction of projection, go for leader, properties, black. So just zoom this. Next, this okay, so just change the colors. Angle between, so this and this 60, this and this, and again this and this, so 72. So angle, comma, angle is 60 degrees. Enter. So comma, angle is 67 degrees. 67 degrees. Next, 72 degrees. So this is the answer. So AB wire is 92.38 mm. So as per the selected scale, it is 9.23 mm, so 9.2 meters, and CD wire 11.9 meters, and EF wire 14.74 meters. So angle AB wire 60 degree, CD wire 67 degree, and EF wire 72 degree. So let's cross check these answers with the analytical method. So this is the pictorial representation. So to find the solution by using analytical method, so vertical post height 15 meters, so wire AB 8 meters, CD 11 meter, EF 14 meters. Now I want to find the length of these wires. So first I want to find the radius for an equilateral triangle with side S. R is equal to S divided by square root of 3. Means S is the side of an equilateral triangle, R is the radius. Radius in the sense, so this is the equilateral triangle of side 80 mm from the center. So this will be the radius. Suppose if I draw an arc, this equilateral triangle should enclose inside this circle. So that is the radius. So how to find that radius is R is equal to S divided by square root of 3. So next, to calculate the length of each wires, so length of wire is equal to square root of vertical height square plus R square. Vertical height square, it is given, so 8, 11 and 14 mm respectively. So substitute length of wire AB is equal to square root of 8 square plus R square. Next, length of wire CD is equal to square root of 11 square plus R square. Length of wire EF is equal to square root of 14 square plus R square. So finally you will get length as 9.24 mm. Length of wire CD 11.93. Next, wire EF 14.74. Next, to find the angle, that is tan theta is equal to vertical height divided by R. So vertical height is 8, 11, 14 divided by R. So we will get theta. So theta 60 degree, 67 degree and 71 degree. So let's cross check these answers with the graphical solution. So 9.2 meters, angle 60 degree, 11.9 meters, angle 67 degree, correct. 14.74, angle 70 degree, correct. So the answer we got is closely matching with the analytical solution. So whatever we did is correct. So this is the solution for this problem. Okay. Thank you. See you in the next video.